Hi guys, welcome back to the class. So in this class now we are looking at how to differentiate with respect to x, which is derivation with respect to x. So now let's assume given y equals to x to the power, let's say y equals to x to the power n. Unlike the first principle that we did, which is quite a bit complex and very long solution, so this is very easy. Now for you to differentiate this, the position is just reduction in power, whereby you bring down the power, then reduce the power by what? By 1. Now for us to differentiate this now, the y over the x. Now the n here will come down. We have an n. We now repeat this x to the power n and remove 1 from the power. If there is a constant here, it means that the power is coming to come and multiply the constants. Unlike if we have a constant, which is y equals to we have in x a, or let's say x to the power p. There's a constant here. So the y over the x here, the y, the x now will be equals to a times the power will come down. We have times p times x to the power. You repeat x to the power p, then minus 1. So we have the y over the x equals to ap x to the power p minus 1. So unlike the one we did for using the first principle, that we have to differentiate y equals to x to the power 2 using the first principle. So for us to differentiate this now, it's very simple. We have the y over the x now. These two will come down. We are having 2 x to the power 2 minus 1. So which is the y over the x will now be 2 x to the power 1, which is the y over the x equals 1 to x. So that's how to differentiate with respect to x. So now let's look at question. So now let's look at these questions now in respect to what we have explained. Now solutions to this now, we have a, we have y equals to x to the power 7. So the y over the x, the y over the x, the y over the x equals to 7. The 7 will come down. We have a 7 x to the power 7 minus 1. So we have the y over the x now have the 7 x to the power 6, which is very simple. So b, we have y equals to x to the power half, which is 1 over 2. So the y over the x, the half will come down. We have 1 over 2 x to the power 1 over 2 minus 1. So then we have to simplify the fraction 1 over 2 minus 1. This is over 1. Find the SM is 2. 2 into 2 is what? 1 times 1 is 1. Minus 1 into, and we have 2 times 1 is 2. So we subtract this, we have minus 1 over 2. So it means if we simplify this, we have minus 1 over 2. So we have the y over the x now equals to 1 over 2 x to the power what? Minus 1 over 2. So let's stop. So now let's look at this. We're having y for c equals to 1 over x to the power 3. So we have y equals to, now we have to change this to index form. We have x to the power minus 3. So dy over the x now. The power will come down, we have minus 3. You repeat this again, minus 3. Then subtract 1. So we have the y over the x now plus the minus 3 x to the power minus 3 minus 1, we have minus 4. So yd, we have y equals to 3, the cube root of x to the power 2. So we have to change this to index form. We have y equals to x to the power 2 over 3. 2 over 3. So then we have the y over the x equals to 2 over 3. Repeat it, we are having 2 over 3 minus 1. Then we have to simplify the fraction. We have, let's simplify the fraction. We have 2 over 3 minus 1, which is, this is over 1. We have the SM as 3. We have 3 in 3 is 1. We are having 2 minus 1 in 3 is 3. 3 times 1 is 3. So which is equals to, minus 1 over 3. So the simplifications of the fraction give us what? Minus 1 over 3. So we have the y over the x now equals to 2 over 3 x is power minus 1 over 3. So if we are to simplify this further now, we have the y over the x now equals to 2 over 3 times 1 over x is power 1 over 3. So which we have the y over the x equals to 2 over 3 x is power 1 over 3. Thanks for watching this video. In the next class, we'll be looking at another part of calculus. See you next time.